to the next segment, that is called the impulse. Okay. Now, what is impulse? So, impulse is basically a kind of force which is a large quantity of force. Okay. So, when I hit a ball, a footballer is kicking a ball, that means he is applying an impulse written by the format G. So, J is the notation which is called the impulse. Okay. And this is the relation which is called the impulse momentum relation. Impulse momentum relation. So, Pi is the initial momentum, J is the impulse, that should be equal to final. So, these are the two segments that we want to discuss over here. Okay. So, what is impulse? Impulse is a force multiplied by time. So, force may be very large force. When a very large force acting on a particle for a very short duration of time, then it gives the impulse product of force and time. Similarly, the force may be on the smaller side and it is acting for a very large duration of time. Then also it is called the impulse. Okay. So, mathematically, it is nothing but F into T. F into T. So, impulse is basically F into T, or I can write that is equals to integration of F D. Okay. That means equals to J number. That means equals to J number. So, if the force is a variable quantity, then you should go for the integration format. If the force is constant, then you write F into T. Okay. So, when the ball is being dropped on a floor, so floor is offering a kind of normal reaction, and that normal is acting as an impulse. That is the impulsive force. Let us do this. So, let us say the ball is being dropped, and once it touches the ground, it is moving with a velocity of, let us say, V, that is equal to 10 meters per second. After hitting the ground again, it moves backward. So, after that, let us say it moves upward with a velocity of, let us say, V, that is also again 10 meters per second. Okay. And between these 2 points, so there is a time difference. So, delta T is the time between which the ball is in contact with the floor. That is, let us say, 0.01 second. Okay. Now, for this situation, I want to calculate what is the normal force acting on this ball. Okay. So, let us say in this situation, normal is acting vertically upward, mg is acting downward. Let us say the ball having a mass of m is equals to 2 kg. The 2 kg ball is dropped and it is hit on the floor and ultimately rebounds back. So, what is the n number? N minus mg should be equals to m into a. The acceleration with which the particle moving upward. Now, what is the acceleration? Acceleration is change in velocity. Final velocity is v. Initial velocity is minus v. Here by delta t. Now, if I say final velocity is upward v, initial velocity is minus v. So, rate of change of velocity. So, ultimately gives 2v by delta t. So, n into 2v by delta t. That is the acceleration part. So, that means n should be equal to this number plus mg. Okay. So, if I put the value, so n becomes how much? N is 2 kg. 2v means 20 divided by delta t means 10 to the minus 2 plus mg means 20. So, this is 40 into 10 to the power 2 plus 20. That means 4000 plus 20 or 4020 Newton. So, this is the kind of normal force acting on the ball when it hit on the ground. So, this normal force is given by the ground. So, this is a quite large value of force. This is a quite large value of force. That means this force is known as the impulsive force. This is known as the impulsive force. The force is known as the impulsive force and the parameter that the product of force into time that gives the impulse. Okay. So, whenever there is a large force, so 4020 Newton is a very large force, which is acting for a very short duration of time. Delta T is 0.01 second. So, that means it is a kind of impulsive. Okay. So, in nature, there are different types of forces. So, this is the kind of impulse force. You dropping the ball and ultimately what you are observing, what is the force offered by the floor on the ball itself. So, that is acting upward. Okay. So, that force is basically acting as the impulsive. So, footballer kicking the ball, he is applying the impulse. Okay. Similarly, whenever I play the game, so I am hitting the ball with the stick. I am hitting the ball with the stick. That means he is applying the impulse. Again, he is also applying the same impulse. Okay. So, whenever I am hitting it, that means there is a very small amount of time of contact between the bat and the ball. So, since the time is very, very small, that means this kind of force are coming towards the impulsive. Okay. So mathematically, what is the definition of impulse is that, so product of force acting on any object with time interval action is called the impulse. Okay. That means what you want to know mathematically from the Newton's second law, I write that force acting on the particle is rate of change of momentum. F equals to dp dt. If I multiply with dt in this direction, so f dt, integration of that will be the integration of dp. And integration of dp is nothing but the p final minus p initial. Now, on the left hand side, that number is nothing but the impulse. So, this number is the impulse. So, integration of f dt is nothing but the impulse. That is equals to p final minus p initial. And that equation can be modified in this form, that is pi plus j should be equals to p final. And all are vector quantity. So, this equation is known as the impulse momentum equation. So, whenever I am getting the sense that force is a function of time, that is a variable quantity, then I also define another parameter that is known as the average force. Okay. So, what is average force? Average force is nothing but the average of any quantity. If it is a time varying quantity, so then you have to do it in the integration f dt in the numerator divided by dt in the denominator. Okay. So, once I do this integration, so what I am getting that, so that is nothing but our integration f dt means impulse. That is equal to p final minus p initial divided by delta t, integration of dt. Okay. So, if I cross multiply, so I am getting f average into delta t, that should be equals to p final minus p initial. So, how to calculate the f average for any particular situation? The f average has to be calculated when you put delta t as 1 second. Okay. So, if you put delta t as 1 second, so f average becomes change in momentum. So, average force acting on any particle is nothing but the change in momentum in 1 second. F average, I can write it that P final minus P initial in 1 second. What is the momentum change that takes place in 1 second? If you calculate that number, then that will give the average force acting on the particle. So, impulse is also known as the change in momentum, defined as the change in momentum. It is a vector quantity and it has the same unit, is equals to force into time or momentum. So, Newton second is the unit for the force into time, or it can be also have the unit of momentum, kg meter per second. Now, impulse is the area under the force versus time diagram. If you have given some kind of diagram, there is a variation of force with time. So, if I take this area, so area of this should be equal to integration of f dt. Okay. So, integration of y dx is the area. So, integration of f dt here will give the area. So, what is that number? That number is nothing but j number. So, impulse is the area under the f versus t diagram. So, if any diagram, force versus time is given, so take the area of the diagram. So, that will give the value of impulse. Okay. Now, this is a kind of impulse. Whenever the one ball is hitting with another ball, so the first ball is giving the impulse on the other ball in this direction. So, let us say blue is giving the impulse in this direction and green is also giving the impulse on the blue in the other direction. Okay. So, there are different situations may be there. So, the collision may be perfectly head-on collision or it will be oblique collision, and there are different situations. The only thing is that in all the situations, the J has to be taken care. Whenever the impulse is coming in, so J has different direction. Got it? Now, similarly, once you hit it, the baseball, so ultimately, you can clearly see that there is a deformation. You are hitting the baseball with a very high speed, high velocity or high momentum. That means a high amount of force you are imparting. So, this is the kind of impulse force, and because of that, the particle may deform also. So, this is a permanent deformation. So, whenever you are applying a very large force, the deformation may be permanent, may be temporary. That means the body will regain its shape. So, initially the baseball may deform, but after some point of time, it will also deform. So, there are two possibilities. So, either it may deform or it may deform. So, let us say that initially the ball is moving in the positive x direction. So, initial momentum is what? Initial momentum is equal to m into u. Now, we apply an impulse in the same direction. Once I apply the impulse in the same direction, so essentially the velocity of the ball is going to increase. Why? So, it is the final momentum P final is equal to m into v. So, what is the amount of impulse? So, J naught, that is the impulse that I am applying, that should be equal to m into V minus E number. Final momentum minus initial momentum. And that means V should be greater than E number. So if the applied impulse is along the velocity direction, so velocity is always going to increase. Okay. Similarly, this man is hitting the ball with a great impulse. So whenever he is hitting the ball with a great impulse, that means the velocity of that ball is going to increase along the direction in which the impulse is being applied. Okay. So let us say for this ball, let us say I am applying an impulse in this direction. J naught is moving along this direction. So there is a momentum change of because of this J naught will be along this direction. Okay. So because of that, there is a one velocity that will be imparted along the J direction always. Okay. So if I apply the impulse now in the opposite direction, if I apply the impulse in the opposite direction, so the momentum will be decreased. So initial momentum in Pi should be equal to m into q. Final momentum is P final equals to m into p, and J is now minus J. So minus J naught should be equals to mv minus mu. Final momentum minus initial momentum. So J naught should be equals to m into u minus v. That means what you can say now the v is less than u number. So if the applied impulse is along the velocity direction, then it will increase, and if it is opposite, then the velocity will increase. Okay. Now let us say the ball is being thrown and it is in contact with the floor for this much amount of time. Okay, so you are asked to calculate the average force exerted by ground on the ball. Now, once the ball is being hit, so there is a contact between the ball and the floor, and because of that, let us say the ball is coming at an angle 37 degree and it leaves at 37 degree. So momentum, so this is the direction in which the impulsive force is acting, because normal is acting vertically. So since normal is acting vertically, so only the impulse is also acting vertically. So you have to take the vertical component. So initially the ball is coming at this angle. So this component should be equal to what? 10 cos 37. That is 8 meter per second. This is a 6 meter per second. Ultimately the ball is moving in the same direction with an angle 37. So that number is again 8. That number is 6. And that number is 8. Okay. So now I can check what is the momentum change along the normal direction. That is 8 minus or minus 8. Okay. So let us say the mass of the ball is given as mass is, let us say 1 kg. Okay, mass of the ball is 1 kg. So delta P, the momentum change should be equal to P final minus P initial. What is that number? That number should be equal to total momentum change is 8 minus or minus 8. That is 16. 16 is the momentum change. Okay. In how much time? This much time. 10 to the power 3, 4, minus 4 seconds. Okay. So in 10 to the power minus 4 seconds, total momentum change is 16. So you are asked to calculate the average force. The average force is nothing but the momentum change in 1 second. So if I want to calculate delta P in 1 second, that will be the value of average force. If average. Okay. So in 1 second, how much momentum is being changed? So that number divided by 10 to the minus 4. The answer is 16 in the power. Okay, so this is the force or the impulse that will be acting on this body or offered by the ground itself. Okay. Now, let us say there is a bullet which is fired and it will get inserted inside this 2 kg. Now you are asked to calculate the distance traveled by the block before coming to this. Now once the bullet is being hit, once the bullet will hit the 2 kg block, so there is a impulse. So for the bullet, impulse is G naught is in this direction. For the block, G naught is in the opposite direction. So if I take the bullet block system together, then what you can say that ultimately the net impulsive force is 0. So I can apply the conservation of linear. So initial momentum is how much? Initial momentum is for 0.5 kg moving with 100 meter per second. So 0.5 into 100 is initial momentum. So finally total mass becomes 2.5. And let us say this particle moving with velocity v naught. So 2.5 into v naught. So 50 should be equal to 2.5 v naught. That means v naught is equal to 20 meter per second. So after the bullet hits the block, now the both block and bullet system is moving towards right with a velocity of 20 meter per second. And since there is a friction, so ultimately the block will come to rest at this position. Okay, why? Because of friction. So in this equation, friction is acting in the opposite direction. So what is that value? That should be equal to mu into mg. Okay. So friction force is mu into mg, and let us say the distance before it stops is s. Okay. So now we have to apply the work energy conservation. So work done by the friction. So work done by friction should be equal to final kinetic energy, A final minus initial kinetic energy. So what is the work done by the friction? That should be equal to minus mu mg into s. And that should be equal to final kinetic energy is 0. Initial is half into small m, half into 2.5. I am writing the value as 2.5. So this number is 2.5. Mu into m into g. That means this number is 2.5. 2.5 because total mass of the system is 2.5. So mu mg is 2.5 minus half into 2.5 into 20 square. Okay. So minus will cancel out. So ultimately h should be equal to how much? 2.5. 2.5 also cancels out. So 20 square by 2 times of mu g. So 20 square by 2 into mu is 0.5, g is 10. Okay. So 10. So ultimately becomes 40 meter. 40 meter. So it will stop after traveling a distance of 40 meter. So this question is solved using the concept of not the impulse, because I have directly omit the concept of impulse and I am applying the conservation linear model. So whenever net force is not equal to 0, that means whenever I feel that impulsive force is coming into the picture, then it may not be possible that I can apply the conservation linear momentum. Okay, conservation linear momentum can only be applicable whenever the net force is equal to 0. Okay. So let us say this is the situation. So there is a variable force F equals to this number acts on a body for the first 2 seconds. Find impulse. So J is what? J is equals to integration of FD. Now, so that means 2t plus 3t square dt integration between 0 to 2. So ultimately 2 into t square by 2 plus 3 into t cube by 3. Limit is from 0 to 2. So t square plus t cube 0 to 2. So that is 4 plus 8, 12 Newton second. So that is the kind of impulse that you are applying on this body. Okay. So this force is variable force. So I have to use the concept of integration to calculate the impulse. So now the diagram is given. So let us say the mass is 2 kg. Initially the body moves with the velocity of 2 meters per second. And you are asked to calculate the velocity of the body after the end of 2 seconds. So the area under this diagram will give the value of J. What is that area? Half base into height. So half into 2 into 10. Force versus time diagram. So 10 Newton second is the impulse acting on the body. So that is going to change the velocity. So 10 Newton second should be equal to P final minus P initial. What is the P final? It is half m into v square minus half m into 2 square. Okay. So half means 20 should be equal to 2v square minus 2 into 4 means 8. So 28. So v square becomes how much? 28 plus 20. 28. Now half m into v square minus half into 2 into 2 square means 4. 4 into 2 means 8. Right. 4 into 2 means 8. So 8 plus 20 is 28. So v should be equal to root of 28. Initial body is moving root of 28. No, root of 28 is not the correct one. So half area is 2, height is 10. So this is 10, right? 10. And final velocity is initially the body is moving at 2 meters per second, right? Mass is 2 kg, half m into v square 20 equals to 2 v square minus 2 into 2 square means 4. 4 into 2 is 8. 8 plus 20, 28 by 2 means 14. Still not correct. Okay. So root of 14 is how much? Root of 14 is more than 4, less than 4. So your answer should be 3 meters per second. Okay. Because 5 is not the correct one, because 5 will be higher side. Okay. 5 on the higher side. Okay, so there might be some issue with the values. Okay, so otherwise it is correct. Okay, so let us say there is a body of mass 10 kg moving with 10 meter per second, gets a jerk. So jerk is another name of the impulse. And its velocity increases to 15 meter per second in the same direction. So here you are applying the impulse J naught because where the velocity will increase. So J naught should be equal to P final minus P initial. What is P final? 15 meter per second. So 10 into 15 minus 10. Okay. The 50 Newton second is the jerk that you are applying. Okay. So J naught is the 50 Newton second. Okay. So initially the body is moving the velocity 10 meter per second, gets a jerk and reverses its direction, such that the velocity changes to 15 meter per second in the opposite direction. Find the impulse given by the jerk. Okay. So that means now you are applying the impulse in the opposite direction, J naught, so that the body starts to move in the direction of the 15 meter per second. Okay. So minus J naught should be equals to final momentum, that means equals to 10 into 15 negative minus initial momentum, that is 10 into 10. Okay. Got it? So that means J naught should become how much? 10 into 15 means 150 plus 100. That means 250. 250 Newton second is the magnitude. 250 Newton second is the magnitude. But you have to apply in the opposite direction. So negative things. So option C will be the correct one. Okay. Now let us say there are two blocks, 2m and 3m, are connected by the string as shown in the figure. A particle m traveling with the velocity v naught collides with the block of mass 2m in a perfectly inelastic collision. What is the meaning of inelastic collision? That means it will stick to it. It will stick to it. Okay. Find velocity of all the objects after the collision. So once the ball is being heated, let us say, if I do this analysis, let us say this is the ball. So on that ball, the impulse is, let us say, R. Okay. On this 2m, another impulse is R. And there is a tension, so that is also becoming impulsive. T is also impulsive. And for this 3m mass, T is there. So now this T is impulsive. Okay. If I take the entire two block along with the ball, you can clearly see that R and T will cancel. Okay. So that means I can do the momentum conservation for this system, entire system. So this is the final situation where this ball is moving with velocity v, this is also moving with velocity v, and that is also moving with velocity v. Why 2m and 3m are moving the same speed? Because they are connected with the string. And because small m is given as the inelastic collision, that means it should move with the same speed as that of the 2m. Okay. So what is the initial momentum? Pi is equals to simply m into v naught. Because all the 2m and 3m are in rest. So finally, all are moving. So final momentum is towards right. How much momentum? Pm plus 2m into 5m plus m in 6m. So P final is equals to 6m into v. So 6m v should be equals to m v naught. 6m v should be equals to our m v naught. So what is v number? V number should be equals to v naught by 6. So this is the final common velocity of all the block, v naught by 6. Okay. So I am not going for the impulse equation. So I am solving this without considering the impulse, because in this system also, if I carefully take all the bodies together, then I am getting the idea that now they are cancelling each other. Okay. Now you are asked to calculate what is the impulse generated in the string. That is T now. Okay. So same question is there, inelastic collision, all are there. Only thing is that you are asked to calculate the impulse. Now we have to say, so I have already calculated the value of final common velocity after the impulse, after hitting the ball. So now this 2m is moving with the velocity v naught by 6. I have got it. So on this 2m, there is one impulse is acting, coming from the small m, is in the direction. Here let us say R, and there is impulsive tension is there. Okay. This is the free body for the 2m mass. So for m, this is the R number. Okay. Now if I write the impulse momentum equation for this 2m block, what I can write? Net impulsive force along the right hand direction. If I say R minus T dt, integration. There is the net impulsive force. Force multiplied by time, that is the net impulsive force on this 2m block along the right hand direction. And I am assuming the right hand direction is the positive one. So final momentum is how much? 2m is moving with the velocity v0 by 6. Okay. And initial momentum is 0. Initially 2m will be at rest. So that is number is v0 am v0 by 3. That is equal to integration r minus t dt. That number. Okay. Now if I come back to the situation for the small m mass. So for the small m, what is happening? So for small m, initial momentum is positive. So for the small m, if I write the impulse momentum relation, so minus integration r dt, that should equal to final momentum. Finally, it is also moving with the velocity v0 by 6. And initially it is moving with m v0. Okay. Initially it is moving with m v0 number. Got it? So what is the answer for the minus r dt number? So r dt number should be equal to m v0 by 6 minus m v0. So ultimately I am getting minus 5 m v0 by 6, or r dt integration, that answer is equals to 5 m v0 by 6. Okay, so this is equation number 2, let us say. This is the equation number 1 I am writing. Okay, now come back to the 3m particle. For the 3m particle, the impulse is in this direction t. So integration of capital T dt should be equal to how much? Then momentum change, final momentum is basically 3m into v0 by 6. Initial momentum is 0. So that means I am getting m v0 by 2. M v0 by 2. So the integration of t dt number. Okay, that is the equation number third one. Okay. Now you are asked to calculate the impulse generated by the string. So impulse generated by string is this number, integration t dt. Now, so m v0 by 2 is the impulse generated by string. Answer will be option number A. If I ask to calculate the impulse generated by the ball, that should be equal to r dt, that should be 5 m v0 by 6. Okay. Now what is the net impulse generated on the 2m? That should be equal to equation number 1. So I got all the information. Okay. So this is the application of the impulse momentum equation. So when you are applying the impulse momentum equation, carefully write the impulse equation and final momentum. Okay. So again, there is a bucket and there is a mass, lock is there, and they are connected with the pulley system. Okay. Now there is a ball of m by 2 mass, hits the bucket with the velocity v0 and sticks with it. Sticks with it means that will also move with the same speed. Now you are asked to calculate the velocity of all the object after the collision. Velocity of all the object after the collision. Let us say in this situation, so again I can see that whenever the m by 2 is coming in contact with the bucket, so it will give an impulse. So for the bucket, if I say for the bucket, so one impulse is provided by m by 2 is in the downward direction, let us say r. So corresponding to that, the tension will be also impulsive. For the small m mass, only the tension will be impulsive. For this ball, r will be in the upward direction. R will be in the upward direction. So let us say after the collision part is over, now since the bucket and the block are connected by the string, so let us say after that the bucket is moving with the velocity v, so this will move with the velocity v, final velocity. And after that, let us say the m by 2 mass is moving downward with the velocity of, let us say, v1. Okay. So now I can apply the impulse momentum relation for each and every ball. So if I apply the impulse momentum for the m by 2 mass, so if I take the upward is positive, so for m by 2 mass, impulse is upward. So r dt, integration r dt should be equal to final momentum. So finally because m by 2 into v1 and initial momentum is m by 2 into v0. Okay. Now since I am taking upward is positive, so downward is negative. So upward is positive, downward is negative, so minus, and that number become plus. Got it? So this is the equation number 1 for the ball. Now for the bucket. So for the bucket impulse is how much? If I take the upward number is positive, so t minus r integration dt, that is the impulse acting on the bucket. That should be equal to final momentum. So finally the bucket is moving downward with the velocity v. So that means minus m into v. Initial momentum is 0. Initial momentum is 0. Okay. And for the third situation, again the upward impulse is t. So integration of t dt should be equals to our value of total momentum in the downward direction. So what is that downward value? So that should be equal to mv. So again positive now. Final momentum is positive, so m into v. Okay. So these are the three equations. So these are the three equations. So you are getting this three equations. Okay. So whenever the bucket and ball come in contact, so what I can do, I can take the, if I add 1 and 2, you add 1 and 2 and subtract with 3. Once I add 1 and 2, then r and r will cancel out. And if I subtract that, then t will also cancel out. So what I am doing, I am adding 1 plus 2 and doing minus 3. Yes. So left hand side becomes 0. So ultimately what I am getting, minus n by 2 v1 minus nv plus nv plus n by 2 v0 is equals to 0. So this minus nv plus nv will cancel out. Okay. So I am getting it, n by 2 v1 should be equals to n by 2 v2 v0. That means what I can get, so 1 plus 2 minus 3. 1 plus 2 minus 3 means not 0. So that should be equal to minus n by 2 v1 plus n by 2 v0 plus minus mv minus mv, that is equal to 0. Nah. So 1 mv, 2 mv, 2 mv, 2 mv plus m by 2 into v1 should be equal to m by 2 into v. So if I cancel m, so v0 should be equal to 4v plus v1. Okay, v0 should be equal to 4v plus v1. Now what is v1? v1 is the velocity of the ball after the impact. Okay, v1 is the velocity of the ball after the impact. That means v and v1 should be same. Why? Because it is given that it will stick with it. So if the ball sticks with the bucket, that means v and v1 should be equal. So that means it is equal to 5v. Okay. So ultimately I am getting v should be equal to v0 by 5. Got it? So initially I am taking the velocity of the ball after the impact is, let us say, v1. But once I read the question, that is, it will stick to it, that means I can now say that v1 should be equal to v. Okay. So ultimately I am getting the v should be equal to v0 by 5. So if v equals to v0 by 5, that is also v1 is also v0 by 5. That means all the particles over here are moving with the speed v0 by 5. Okay. So answer for this problem will be v0 by 5 and v0 by 5. Got it? So this is how you have to approach the problem. Where you are writing the impulse momentum equation carefully, taking the proper sign. So in the entire situation, I am taking the upward is positive. So correspondingly, whatever is the momentum that comes in the upward direction, that is positive. And whatever the impulse that is upward, that is also positive. Impulse downward is negative. So this R is positive and that R is negative. So for the bucket, I am taking T minus R. And for the ball, I am taking plus R. So with the proper notation and proper sign, you have to write the impulse equation. Ultimately, if you rearrange the left side, so it will always becomes 0. Okay, you have to make it. Otherwise, you're going to do the calculation. So you have to arrange either by addition or subtraction, or it may be possible that you have to multiply some equation with some number. Okay. So it may be possible that there may be 1, 2 comes. So then it may be possible that you have to multiply equation number 1, both side by 2. Then you have to do the addition subtraction. So ultimately you have to rearrange the entire equation so that on the left hand side you have to get the 0 number and then you can write the other.